Hello everyone and welcome to my workshop. Today we're going to be taking a look at the newest version of the Raspberry Pi OS. We'll check what's new and also how well it runs. And nowadays you can't talk about Raspberry Pi OS without talking about the Imager application. Imager makes it super easy to download an OS, flash it to an SD card, and even customize it before you boot your Pi for the first time. Raspberry Pi recently launched Imager 2.0. Although the new Imager has a different look and feel than the first version, it functions pretty much the same way. The main difference is that it has more of a wizard interface and it walks you through the customization process. You can enter a username, password, Wi-Fi credentials, configure your SSH key, all the user stuff that you could do before. But starting with Imager 2.0, you can configure a key to log into Raspberry Pi Connect right away. This means you can flash an SD card and have remote access to your Pi from anywhere in the world without ever having to connect a mouse and a keyboard to it. And that's pretty awesome. Imager will take you to the Raspberry Pi Connect website so you can get an auth key and add to your customization. But the button to jump to the website is not working on Linux at the moment. You can still log in to the website, copy and paste the auth key, and move on with the customization process. I hope they address this in the next version, as this step works just fine on Windows. And can you believe that the OS customization menu was a hidden feature in the first version of Imager? What were they thinking? All of the OS customization gets saved in a Cloud-init format. The same time they released Imager 2.0, they also released a new version of Raspberry Pi OS that is compatible with Cloud-init. Cloud-init is usually used to provision virtual machines in a cloud environment, but it's also used to configure bare metal machines for their first boot sequence. Like we saw in Imager, you can create users, set up Wi-Fi, and other basic configuration to an OS. But you can do way more than just that though. Want to make sure your favorite system monitoring tool is available right away when you log in for the first time? No problem. Just add it to the list of packages that will be installed on first boot. I test a lot of things on Raspberry Pis and sometimes I just have to scratch everything, restart with a new image. I save all of my project files on a NAS so I don't lose them if I have to nuke the OS and start fresh. Before Cloud-init, I had to go through creating the credentials, manually editing fstab, and connecting to the NAS to start working on the project again. Now, I can just copy over a Cloud-init file with all of the commands that I needed to set up the connection to my NAS. Wait for the Pi to boot up for the first time, and there you go. Casa NAS is already connected and ready to use. All of this was technically possible with a first boot shell script, but you know, a shell script is not as user-friendly as adding an easy-to-read Cloud-init configuration file. I think Cloud-init on a Raspberry Pi is pretty cool. You could create templates and have different configuration files for different applications. Someone could have a web hosting template or a Python environment template. Just load your Cloud-init template in the boot folder and you have a fully configured Pi from the get-go. It will be cool to see what the Raspberry Pi community would do with this. Trixie is the new version of Raspberry Pi OS and it is based on Debian Trixie. It hasn't been out for a little while right now, but I figured I would take a look at how well it works on a few different Pi models. Raspberry Pi supports almost all of the computers they have ever made, which is very refreshing in a world where companies release new products to make new sales and stop supporting their old ones. I'll first test the new OS on a 16GB Pi 5 and then on a 4GB Pi 4. Then I'll test the same OS on a Pi 3A Plus, a 02W, and a Pi 1B+. These three boards only have 512 megabytes of RAM, but very different CPUs. Pi 1 has 700 MHz of clock speed, the 02W 1 GHz, and the Pi 3A Plus has 1.4 GHz of clock speed. Although the Pi 3A Plus has higher clock speed, it's a little bit older than the 02W. We'll see if that makes a difference. I also have an OG Pi Zero, but I don't know if I have the patience to wait for that to boot. You'll see why later in the video. I tested all of these boards with a desktop image, but I also tested the Pi 1 and the Pi 02W with a light image, because the desktop environment might be a little bit too much for these two to handle. Let's start with the Pi 5 and take a look at what is new in Raspberry Pi OS Trixie. Although it is possible to upgrade your system from Bookworm, the previous version, it's not recommended to do that. For this test though, I started with a brand new Trixie image. Even though the first boot performs a restart right away, it is pretty fast at just 50 seconds from pushing the button to operating the OS. Subsequent boots are even faster at just 24 seconds, so chapeau Raspberry Pi. I did test booting from SSD on the Pi 5, but that did not change how fast the Pi 5 boots. I have criticized how dated the Raspberry Pi OS looks out of the box. They made some improvements with some new icons and new theme, but still, I wouldn't call this modern. You can install other themes, other desktop environments, and customize your OS, but it would be nice to get a good looking desktop from the first boot. But this is a Raspberry Pi and this look is kind of cool. I don't know. Let me know what you think in the comments. The interface is super responsive and navigating the web feels like you were on a desktop machine. Really, it's pretty hard to tell the difference between using Chrome on a Pi 5 and using Chrome on my laptop. YouTube at full HD definition plays just fine, but things get a little ugly if you bump it up to 4K. It's playable, but not a great experience. Raspberry Pi advertises the Pi 5 as a 4K computer, and sure, it's capable of driving a 4K display, but it certainly struggles to play 4K content. I have showed how 4K YouTube video works on a Pi 5, and I always get comments that I shouldn't use YouTube as a video playback test. So, well, here's me in 4K 30p video in VLC. It plays really well with no skips, no jumps, and I even pulled up the stats at the end and there were no drop frames. Are you guys happy now? How about 6K 30p open gate videos? Things are supposed to be moving on the screen right now. And as you can see, 6K video is not really playable on the Pi 5, at least not these compressed MP4 files that came straight out of my Fuji camera. Back to the desktop experience though, did you know that all of the desktop images are from Raspberry Pi employee? His name is Greg Annandale, and you can check out his photography website that I linked in the description below. There's a new control center in Trixie which looks nicer than the previous version, but nothing earth-shattering here. They also added the ability to download paid content through the Bookshelf application. Free content has always been available, but now you can log in with your Raspberry Pi ID and have access to all your paid publications. At first, I thought that was a little bit gimmicky, but now I kind of appreciate it. As a contributor, I can download the magazines directly to my Pi as soon as they're available. I always forget to download the magazines, and by the time I would download them, they would have been made available for free anyway. So now I just need to come up with a script that can download this content and send to my e-ink notebook. When Raspberry Pi OS Trixie first came out, it did not have support for the AI hats, and that was stopping me from using it. I have been working on a video exploring zero-shot computer vision projects on the Raspberry Pi, and lack of AI HAT support was a no-go for me. Keep an eye out for this video that's going to come up in the next few weeks. So Raspberry Pi OS Trixie on the Pi 5 is as good as it gets. Now let's see how it performs on other Raspberry Pis. Booting the same OS image on the Pi 4 takes about 45 seconds. That is slower than the Pi 5, but it's still pretty fast. The desktop experience on the Pi 4 is noticeably slower. Not super slow, but you can tell it's not the same as on the Pi 5. YouTube experience on the Pi 4 is a completely different story. It struggles a little bit to play 1080p content, and 4K videos are a no-go. Keep in mind that the Pi 4 was launched in June of 2019, so this computer is almost 7 years old. Aside from being slower than the Pi 5 and not having the PCIe port, it has pretty much all the same basic features and gets the same OS updates, which is pretty awesome. But the lack of PCIe means it's a little bit more limited than the Pi 5. For instance, you have to plug in a USB AI accelerator or a USB to NVMe adapter instead of just using the faster PCIe lanes. Depending on the project you're working on, a Pi 4 might be more than suitable for the job, and you save $17, which is not nothing. I mean, you can buy 2 dozens of organic eggs at Whole Foods for the same price. I would totally use a Pi 4 for coding projects or just hosting local services. Did you know that our PiLocator.com is hosting a Pi 4 with 8 gigs of RAM? A full-blown website on a Pi 4 in the cloud. Next, I moved to test the Pi 3A Plus, and that's where things got a little bit slow. The Pi 3A Plus was released in November 2018 and only has 512 megabytes of RAM. It was priced at $25 at the time it was launched 7 years ago, and it's still priced $25 today. So it kind of tells you you're not going to get a lot of performance out of this thing. After launching Chromium, I was presented with this warning saying that it's not recommended to run Chromium on devices with less than 1 gig of RAM. The browser window finally loaded, but it was unusable. I tried Firefox, but got the same warning, so I gave up using an internet browser for now. Navigating around the OS is slow, and it's hard to tell when you have clicked on something because of the substantial lag. VS Code took forever to launch, and then it just hung up and crashed. Even Thonny, a lightweight code editor, takes a while to launch and is laggy. I'll let it play in real time how long it took to just maximize the window. I tried playing a 1080p MP4 video and it was not able to handle it. Things are so laggy I wasn't even sure if I was trying to play the video or not. But it had double-clicked from the desktop, so I let it try to do its thing. After over a full minute of struggles, it brought the whole system down and just rebooted. And at this point, I started to question my decision to test a full desktop image on the 02 and the Pi 1, but there's no turning back at this point. I'm just going to have to lower my expectations for the next 2 tests, but maybe I'll be pleasantly surprised. We'll see. So I wouldn't really call the Pi 3A Plus a desktop computer, but it's only $25 and it can run Linux and it has built-in Wi-Fi and Bluetooth. It's definitely more of a platform for embedded devices than a desktop computer. Moving on to the 02W, and just to be clear, I don't expect the 02W to be a full-on desktop computer. That was never the point of this board. I just want to see if it works and what we can do with it. At first, the OS seemed a little bit snappier than the 3A Plus. I wasn't sure if my brain was getting used to the lag between clicking and then something actually happening on the screen, or if the 02W was actually faster than the 3A Plus. But then I tried to play the same 1080p video that made the 3A Plus crash, and it sort of played. There's some serious choppiness going on here, and the interface is completely unresponsive, but at least it didn't crash. I'm starting to think the newer architecture of the 02W does make it a little bit snappier than the 3A Plus. Launching an internet browser was still a no-go, so I gave up again. Updating the OS takes some serious patience. First, it only has 2.4 GHz Wi-Fi, which is pretty slow compared to today's Wi-Fi standards. And second, installing all downloaded packages with only 512 megabytes of RAM takes a wee bit to complete. But we're talking about a $19 Linux computer. Let's cut it some slack. Terminal, as expected, works perfectly fine. But if you're going to stick with Terminal, I would recommend using the light version of the OS, which doesn't have the graphical interface and it runs really well on the 02W. And by the way, if you're still watching this video, thank you. I really appreciate it. You might have noticed my videos don't have any sponsors and I don't try to sell you anything. It's really just me testing this stuff and showing it to you. If you have made it this far, it kind of means you like the video. So the best way to support this channel is to just share it with someone you think is going to like the video or just post it on social media. And if you're going to leave a comment, make sure to mention Fruit Computer so I know you watched most of the video. And thanks again. And finally, we'll see how well the newest version of Raspberry Pi OS works on the Pi 1. This is the B Plus version, so not the OG Pi 1, but the specs are basically the same between the OG Pi 1 and this one that I have here. They have the same CPU and the same amount of RAM. Up to this point, I was just removing the SD card from one device and plugging into the next, but the Pi 1 is not compatible with a 64-bit OS. So I had to flash a new copy of the 32-bit version and then fire up the Pi 1. And it took a little while to boot up for the first time. It took 10 minutes. Subsequent boots only took 5 minutes. That was painfully slow. But this 12-year-old computer is still getting software updates and is capable of running the newest version of Debian OS, which is very refreshing in the world of planned obsolescence that we live in today. Most $400 phones only receive updates for a couple years, and that's it. I always forget these don't have built-in Wi-Fi, but this 12-year-old Wi-Fi dongle also works and is supported out of the box. And don't get me wrong, everything is super slow. Here I'm typing and the graphical interface can't even keep up with it. So if you have a Pi 1 just laying around in the drawer, yeah, go for it. Put it to good use. This will be perfectly fine just running some Python scripts in the background. But I wouldn't run something like Home Assistant on it though. All in all, Raspberry Pi did a great job making it super easy to get started with a new Pi computer or a really old one too. And with that, I'll see you in the next one. That was long.